Uh, Johnny decides to take his employees to the beach. High tide occurred at 10:46. Somebody measured the depth at 9 feet. And then later, 6 hours and 12 minutes later, it's low tide. So we got high tide and low tide. High tide was 9 feet. Low tide is 4 feet, which means in the middle would be the middle of 4 and 9. 13 divided by 2 is 6.5. Now, starting to mark this out, we've started at high tide. It then goes down to low tide, and then it's going to come back. So that's going to be a cosine. This high tide happened at 10:46. 46 minutes would be 0.76 repeating. 766 repeating. So that's 10.7 and then a whole bunch of sixes repeating. Then it is 6 hours and 12 minutes later. It's down here because the entire period is 12 hours and 24 minutes, which would be 6 hours 12, 6 hours 12 again. And that's the entire period, 12 hours, 24 minutes. 24 minutes, similar to what we just did, would be 0.4. So it's 12.4 is the period. So we know that we are writing a cosine equation, a positive cosine equation, shifted to the right to 10.766, shifted up to 6.5. We know the period, but we don't know B, which I call the period changer. The period is always equal to 2 pi over B. So the period, 12.4, is equal to 2 pi over B. Solving for B, you do 2 pi divided by 12.4. And that can reduce. I'm going to keep the decimal in there, but reduce everything by 2. We'll go to pi over 6.2. So our equation is a positive cosine with an amplitude of 2.5. From 6.5 to 9, it's 2.5. So the amplitude is 2.5 and it's positive cosine. Then we put B, pi over 6.2. X shifted to the right to 10.766 repeating. Plus our vertical shift, which was right up here to 6.5. There it is, a little bit easier to read. So that's our equation. We can type that into our calculator and use it to answer these questions. 7 a.m. Remember, with this, we have to use basically military time. So it's got to go from 0 hours to 24 hours, which means 7 a.m. is going to be x equals 7. 9 p.m. is going to be 12 plus 9 is x equals 21. So for this one, since we did pi over 6.2, our calculator needs to be in radians. Go to the graph, we'll type this in. 5 cosine. I'm going to type a whole lot of 6's since that's what they're supposed to be. Plus 6.5. And when I hit draw, we don't see anything because we didn't fit our window on the calculator to the sketch that we started here. Y needs to go from at least 4 to 10 or 4 to 9. So I'm going to do 0 to 10. Our X is time. That's going to be 0 through 24 hours for the whole day. Now we can see it. If you get a straight line, that's because you're in degrees. If it doesn't have the curves to it. So now we can find the depth at x equals 7 and x equals 21. So that's a G-solve y-calc with x equals 7. 5.671. And then again with x equals 21. There's our two depths. And then the first time that the depth is at 8 feet, that's going to be an x calc. Because we know the y value this time. Y value is 8. Happens very close, very soon. So that's right after midnight, 0 hours. So that's right after midnight. So it's going to be 12 something a.m. 0.196. I'm just going to keep my calculator there, so that stays as my x value. Go to the regular calculator portion. There it is as our x value. If there was an hour on it, I would subtract it. So I'm just left with 0 point whatever, but that's what we are already because it's midnight, just after midnight. And then I want to change that to minutes, so multiply it by 60. The 11.8 minutes, which means when you look at the clock, it's still going to read 12:11. So that's the time I want you to put on there. If you rounded to 12:12, I'd be okay with it, but the clock would still read 12:11. It hasn't moved yet.